Today, we would like to introduce how to use our PDF1000 DC system earth fault detector. The device consists of a main unit and a receiver. The receiver is handheld. The common grounding systems in China are 110 volts and 220 volts. This system can cover DC power supplies within 400 meters. It can detect ground faults in 99.9% of DC systems on the market. Before use, check with a multimeter whether the positive, P+, or negative, N, terminal is grounded. It's rare for both P+ and N to be grounded at the same time. You'll almost never encounter this scenario. Test by measuring P+ and N with a multimeter, should be 110 volts each in a 220 volt system. A 220 volt system splits into plus 110 volts and minus 110 volts. If a fault occurs, a voltage drop will appear when measuring P+ and N. Thus, the multimeter helps determine whether P+ or N has the ground fault. Without a multimeter, you won't know whether P+ or N is faulty. This leads to wasted effort. To save time, always check P+ and N grounding with a multimeter first. If the multimeter detects P+ or N grounding, clip the test lead to the faulty terminal. Then, connect the black lead to ground. Clip the red clamp to the faulty terminal. Clip the black clamp to ground. Power on the PDF1000 to begin testing. The output indicator LED will flash. This means the device is actively sending signals. Note, some DC systems have leakage protection. The signal may trigger a leakage protection alarm. If only an alarm sounds, ignore it. It won't interfere with the test. But if there's auto cutoff protection, the DC system will shut down. In this case, the PDF1000 won't work, because the DC power is cut off. You must disable the protection first. After wiring, check the handheld receiver. The receiver has clamp A and clamp B. Clamp A is larger, clamp B is smaller. DC systems can be series, tree-like, or parallel. In series systems, current branches downstream. The number of branches increases. Upstream current is stronger. Main busbars/cables are thicker, use clamp A. Clamp B won't fit here. Use the larger clamp, A, instead. Some systems have tight, tangled wiring in panels. Clamp A is hard to use here. Use clamp B for thinner wires. Choose the clamp based on the situation. Proceed with the measurement. Clamps are directional, align with current flow. Match the clamp's direction to the current path. The device displays real-time resistance, ohmega. Check the reading. Attach the clamp. Use only one clamp at a time. Never use both clamps together. Readings include resistance and insulation level. Insulation levels range from 0 to 19, higher equals better. A higher level means better insulation. Move the clamp step by step downstream. Monitor the insulation level of the faulty phase. If the insulation level drops, that branch has a ground fault. Ensure proper current direction when clamping. Follow the branching path of the DC system. Record the readings. Use insulation level plus resistance to locate the fault. The device has limited input power. Systems with many branches may have weak currents. High internal resistance increases losses. Current can become very small. Electrical noise, e.g. substations, can interfere. Avoid touching the clamp during measurements. Touching it causes inaccurate readings. Release the clamp after placement. Keep it steady for stable readings. Wait for the reading to stabilize. Now, the reading is accurate. You should know the system's layout. Locate the correct wire to measure. The biggest challenge is knowing the system well. If the receiver emits a signal but the clamp isn't on the correct branch, the reading will fluctuate randomly. Or it'll be meaningless. The clamp should only receive signals from the main unit, but electrical noise can interfere. Thus, the key difficulty is tracing the DC system's path and branches.